just to make sure that we have under control our sum and difference identities, let's do a practice problem, and let's pick kind of the hardest ones to work with. They aren't hard, they just have extra work to them.
This is hard.
So we'll do a tangent. So we'll do the tangent of, how about, 255. Have we done that yet? I don't think so. Let's do the tangent of 255. This is not in the packet. We are ahead of where I thought we were. We're amazing. I just made it up. So this is for your notes. And this is just to make sure that you haven't forgotten what 5.3 is about. The quiz you just took was 5.2. That was doing the identities. Now we are going to just do a quick review of the sum and difference identities, and we're going to jump into 5.4. All right. So here we go. How do we start? How do we find the tangent of 255? What do we have to do first? Break it up. And when we see a 5, we might want to think about 45. And then if we did that, which we don't have to do, but if we did it, it would be 45 plus 210. Now, as long as 210 is special, it's all good. Yes, 210 is special, Brenton, because when I draft 210, or draw 210, butterfly bow tie, it is going to be a 30-degree angle. So I am going to label the sides of my 30, 60, 90 triangle. That's 210. Everybody with me? 210. Notice the negatives. Do not forget the negatives. It will be trouble.
And the 45 is what?
And the 45 I'll draw, but you may not need to draw that one every time because you've used it so much. You probably already know, but there it is. There's the 45. So we've decided to break this down into 210 and 45. Are there other ways you could break it down?
Yes.
Yes. So there is no single way to break it down. You can use whatever combination you want as long as they're special.
Will you end up with the same answer?
You will end up with the same answer. Now, the work part will look different. These intermediate steps will look a little different, but the answer will be the same.
So now you put in that little
Okay, so
equation.
now we're going to use our sum and difference identities.
So it's going to be plus.
So, yes, right. So this is the tangent of u plus v. I think of it as the tangent of the first plus the tangent of the second over 1 minus the tangent of the first, tangent of the second. But you think of it however you want. If you want to think of it as u's and v's, that's fine. If you want to think of it as x's and y's, p's and q's, I don't care. But you have to know tan plus tan over 1 minus tan tan. Alright, so now we just go to the pictures that we drew and we plug in the values. So what do I put in for the tangent of 45? 1 plus, alright, what's the tangent of 210? Be careful. The tangent would be
3 over 3.
It'd be negative 1 over negative root 3, which is 1 over root 3, which is root 3 over 3. So that's the number that's going in here, root 3 over 3. And then 1 minus 1 times root 3 over 3. Right. So it's 1 plus root 3 over 3 over 1 minus root 3 over 3. Now, nothing cancels. Right? Do not even think about it. Remember, when you've got adds and subtracts in the problem, the only way to cancel is to factor. Nothing factors. So you're not going to cancel anything out. Jack.
Like where you have 45 plus 2 at the top. No,
Up
up there.
here.
When would that be a minus?
If the angle you were trying to get, you had to subtract to get it, So like if you were doing 15, if that had been 15 degrees, you would be doing the tangent of 45 minus 30, because that's how you get 15. And there are probably angles you could subtract to get 255 too. You could do 300 minus 45. That would do it for you, and you'd be using the minus formula. Now, this is a big fraction that has a whole bunch of little fractions in it.
Yes.
We need to multiply by 3 to get rid of those fractions. So I'm going to multiply everything by 3. I'm still going to have the big fraction, but now all the little ones are going to be gone, because what am I going to have here? Remember, you're multiplying.
3 plus
So
root
you're
3.
going to have 3 plus root 3
Then 3 minus root 3.
over 3 minus root 3. Now, it's still not done, but it looks a whole lot better than it did a minute ago. Now, you have a radical in the bottom, which isn't allowed to be there. So we'll multiply by the conjugate of the denominator.
So 3 plus root 3.
So 3 plus root 3, top and bottom. Now we have a couple of giant FOIL problems. So we'll FOIL out the top, which will be first, outside, inside, last, over, first, outside, inside, last.
9 plus 6 root 3 plus 3 over 6.
So it's going to be 12 plus 6 root 3, right? Because I can add those together. Over, those cancel, over 6. And then what do you notice?
Oh, you can divide by 6.
You can factor a 6 out of the top, right? And because you can factor it out, you can cancel it.
So 2 plus
So 2 plus root 3 is your answer. Now, the trigonometry ended right here. All the rest of that is just your arithmetic stuff to clean up the answer. So all that you already know how to do. You just have to take the time and the patience to do it. That mess doesn't happen with the sine and cosine because they're not fractions. I mean, the formula is not a fraction. This is going to happen every time you do a tangent.
What if you forget to multiply by 3? Will you still be fine?
Well, then you're going to multiply top and bottom by the conjugate of this. So you're going to be foiling with fractions.
It wouldn't be bad.
And then none of this is too bad. It's just a hassle. But you're going to end up with a fraction that you're going to have to get rid of because it is not appropriate to leave a complex fraction. So since I know I'm going to be using the conjugate, I'm going to clear it out right now. But if you want to go ahead and clear it out at a later stage, that's fine. But at some point, you're going to have to clear it out. Okay? All right. One more quick review just to make sure that we got this. How about a problem that says something like simplify cosine 20 cosine 13 plus sine 20 sine 13. Now the only purpose of this problem is to see if you know your identities or not. I mean, that's it. I'm just checking to see, do you know your identities? So let's just pause a moment. It's cosine, cosine, sine, sine. Now what pattern is that? You've only got 3 patterns, sine, cosine, tangent. The tangent's the one with the fraction. Which one is this? Cosine, cosine, sine, sine.
Cosine.
That's a cosine formula. So then you gotta figure out, okay, is it the cosine of u plus v or u minus v?
Minus.
Minus, because in the cosine formulas, they don't match. The sine formulas, the signs are the same, S, 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 S. Your u is 20, your v is 13, so the answer to the problem is cosine 7. All right, one more. Sine 58, sine 100 plus, no.
Can you do that? No.
Yeah, you can actually, I'm just not ready to trick you yet.
Is that the flip of the cosine?
No. Oh, well, by flip, I'm not sure what you mean. Let me get this written down so I can. We'll do it in a minute since I just started. I didn't mean to put a tricky one down just yet, but I'll go do a tricky one next. All right, what do we got here? Sine cosine plus cosine sine. That's a sine formula. And then I have to decide, once I figured out it's a sine formula, because that's the sine pattern. Sine, cosine, cosine, sine is the sine pattern. Now, is this going to be u plus v or u minus v?
Plus.
It's going to be a plus, because in the sine formulas, the signs stay the same. So it's 58 and 100. So this is the formula for the sine of 158. All right, now here's the tricky one that I accidentally started doing, but it is on some of the practice quizzes and things. This happens. Sine 10, sine 7, minus cosine 10.
Don't hate, because I like Precal.
Cosine 7. All right, now, you're thinking to yourself, as you should be, Mrs. Ford, there is no formula that says sine, sine, minus cosine, cosine.
Is it cosine?
I think it's cosine 7.
No, there is no formula that says this. Would you agree, though, that I could write it this way?
Yes.
Would this be the same thing? Now look at it carefully. Would that be the same thing as I started with?
Yes.
Now there is a formula for this.
That's the cosine.
What is the formula for that? Cosine
Oh, what's that? 10 plus 7.
10 plus 7.
So 17.
So this bracketed or parentheses part is the cosine of 17. It's the opposite of the cosine of 17. Not the reciprocal. Don't say anything about secant or anything. No, that would be silly. It's the opposite. It's the backwards. It's been times by -1. Okay? All right. So that's a great question. I'm glad we talked about that. All right. Now today, we're going to talk about the last set of identities that you are responsible for. And those are what we call the double and half angle identities. So, by double angle, we mean sine 2x. That's twice 2x. Alright, so it's 2x, twice the angle. You look on your green sheet, I believe these are on the back, and they're called the double and half angle. This is a double angle identity. Now, the identities that we've been using are called the sum and difference identities because they deal with u plus v. These guys deal with 2x or x over 2. Double angle, half angle. All right, so let's talk about a couple of different kinds of problems that you'll be doing this or doing with these formulas. One, the most basic kind of problem is this. Tan x equals -3/4 x in quadrant 2. Find sine 2x. All right, so they give you some given, and then they ask you to find the sine of 2x. But this is actually pretty simple. I mean, obviously you got to know the formula, so that's the hard part. But right now, look on your green sheet. What's the formula for the sine of 2x?
2 sine cosine.
2 sine cosine. So this formula is a little easier than the sum and difference because there's only 2 numbers you need to plug in. To evaluate this, you need to plug in something for the sine and something for the cosine. remember with the sum and difference ones, remember how there were 4 numbers you had to fill in? Because you had sine, cosine, minus cosine, sine, or something like that. This is a little simpler, only 2 numbers. Where am I going to get these 2 numbers?
From the angle of negative.
From the given. So I'm going to draw a picture of the given, which is in quadrant 2. The tangent is 3/4. Make sure you put the negative on the right number. And the hypotenuse by the Pythagorean theorem will be 5.
No, it's 4. How do you know this is the second quadrant?
It says.
Oh,
My thoughts exactly. All right. Now, I'm going to plug in sine and cosine. So here we go. What's the sine? 3/5. What's the cosine? Negative 4/5. Now you're going to multiply these 3 fractions together. And you aren't going to mess this up. This is like 2/1. We multiply straight across. So what do we get on the top?
6/5.
What do we get on the top?
Negative 24.
Negative 24. What do we get on the bottom?
5.
What do we get on the bottom? 25.
Oh.
So the answer to the problem is negative 24/25. When we multiply fractions, it's top times top, bottom times bottom.
Can we reduce it?
Is that reduced?
I think so. No, you can't. You can't.
If it reduces, you're going to want to reduce it. But it doesn't reduce.
Is this by 4?
This is 5/4.
Keep it up there.
Okay, let's try another one. This time let's do a cosine. Let's do, let's say the cosecant of x is negative 13/5. X is in quadrant 3. And let's find the cosine of 2x. Now, look at your green sheet. What do you notice about the cosine of 2x? There's 3 of them, right, Annie? There's 3 of them. Now, kids, look. The reason there are 3 of them is, well, first of all, the main one is cosine squared minus sine squared.
Is that the one we're going to use?
That's the main one. There will be problems. Okay, every problem can be done with that one. All right? But there will be problems when it will be easier to use one of the other versions. Now, the other versions, you already know where they came from. Cosine squared can be written as 1 minus sine squared, right? So if you did that, if you changed your cosine squared into 1 minus sine squared, you'd have 1 minus 2 sine squared. Isn't that another one of the formulas for the cosine of 2x? And it was found by simply changing cosine squared into 1 minus sine squared. Well, go back up here. What if I change my sine squared into 1 minus cosine squared? So I've got cosine squared minus sine squared. What if I changed this into 1 minus cosine squared? What's going to happen?
2.
I get cosine squared minus 1 plus cosine squared, which is 2 cosine squareds minus 1, which is your third version. So this is the main one, but by manipulating, you can get this one or this one. Now, personally, in this problem, given what I've been given, I'm going to use this formula right here. Because if the cosecant is negative 13/5, then the sine is negative 5/13. Would you agree? If I use this version of the formula, what is the only thing I need to know? The sine, which I know. So I don't need to draw a picture and all that stuff unless I'm using one of these formulas. Then I need to draw the picture because I'll need to figure out what the cosine is. 1 minus 2 times negative 5/13 squared. That's what this means. The sine is negative 5/13. So I have 1 minus 2 times negative 5/13 squared. All right, what's 5/13 squared?
25 over
169. What's 2 times 25 over 169?
50 over
50 over 169. What do I do when I have 1 minus 50 over 169? Get a common denominator. So 169 minus 50 169
What is that, 119?
leaves me with 119 169 as the answer to the problem. So there's a lot of arithmetic, but the double angle formulas are easy to use. The halves are a little bit harder. Moral of the story, while you're finished writing all this down, the cosine 2x is the formula that has multiple versions. Memorize, I don't care how many you memorize, but you gotta memorize at least one of them. And if you're only gonna memorize one, I would suggest this one right here. Every problem is gonna be doable with that one. Sometimes you just have to do a little more work. Okay? I will do one more, we'll do a tangent. Alright, so here we go. Let's say, oh my. Let's say the cosine is negative 3/5, and we'll put it in quadrant 3, and we want to find the tangent of 2x. So this is the problem. You got your given up there on the top, and then you've got your question. What is the tangent of 2x? So, what needs to be done? Cassie's looking at a green sheet. That's what needs to be done, because you need a formula. There's a formula for the tangent of 2x. What is it? There's only one. What is it? 2 tan over 1 minus tan squared. So there's the formula we're going to use to do the problem. Now, I need to put numbers in here. I need numbers in there. Where am I going to get the numbers that go in there? From the given. But I'm going to have to draw a picture and figure out what the tangent is. So it tells me I'm in quadrant 3, and the cosine is negative 3/5. Which means, yes, 25 minus 9, this is going to be negative 4. Don't forget the negative.
No. For 1 minus.
Mallory, what are you doing back there? What's in your sweatshirt pocket? Nothing? Pay attention up here. So negative 4, everybody got 4 on the negative? Or negative on the 4? Alright, so what's the tangent? 4/3. So we have 2 times 4/3 over 1 minus 4/3 squared.
Now, instead of doing that, could you also do secant? And do over 5.
1 plus tangent squared is secant squared.
Right.
So I wouldn't do that. Alright, so what do I end up with on top? 8/3. Remember, this is 2 over 1. Do not mess that up. It's 8/3 over 1 minus 16/9. Now, you have to simplify that, and I don't care how you do it. It makes no difference. Just get it done. I'm going to multiply everything by 9 because that happens to be my favorite way to clean things up. So my 3 is going to cancel, and I'm left with 24 on the top, and 9 minus 16 on the bottom, so my answer is negative 24/7. Now, If you clean it up a different way, if you get a common denominator down here, and then multiply, you should get exactly the same answer that I get. Okay? On Thursday, wait, you think, I don't see you tomorrow. On Thursday, we're gonna have a quiz over 5-1 to 5-3. Okay? 5-1 to 5-3. Which means, what formulas do you have to have memorized? Not all of them. Everything on the front page. Right. Everything on the front of the page.
Wednesday.
That will be Thursday.